But I can have 3, 4, 5, 6, 7, 9, 10 stages, but the question has to be simple. Like all of them or none of them, like that. So if I have some of the questions like that, 20 women, 30 men, okay, this is a group in a company or something like that, and then you're selecting 5 people. You're selecting, okay, whatever, 7 people, anything. Find the probability that all of them are women. No. You always answer so quickly. Think one by one. The first guy selected, what's the chance it is women? 20 over 50. The second one selected will be women, 19 over 49, because it keeps reducing, right? And then keep reducing, because every time you select 18 over 48, and then 17 over 47. How many of these? 7. It takes you a lot of time to do that, right? And then you multiply them, when you add them, multiply. This is a multiplication rule. This is a different, probabilities on the branch that give you the outcome. So that's 16 over, how many? 1, 2, 3, 4, 5. I need to have conservative for the space. So that's it. 46, 45, 44. And then I have to multiply all these 7 fractions to get the probability. Yes, that's the probability that all of them women. We multiply to get one outcome. Any outcome. This is one outcome. This is, see, the tree diagram looks like this. Women or men, first one. And then women or men, so on. So you want one outcome at the end, which is women, 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 women here. That means all women. No, use a this. You have a multiplication rule today. You have a multiplication rule today. So to get the outcome probability, which is www, how many? That's one outcome. After 7 selections, 7 steps. So to get one outcome, you multiply everything. You have a probability here, this number, this number, this number, this. You multiply all of it to get one outcome. If you need more than one outcome, each one of them will come from multiplication, and then you add them.